Hi everyone, we are going to start Module 6 today, and we're going to talk about area and then volume. So let's start with area. We're going to talk about quadrilaterals today. So let's review. We learned about quadrilaterals earlier this year. Let's review some of the stuff we learned. So number one, a parallelogram is a quadrilateral. Now quad means four. So quadrilateral means a four-sided polygon. So parallelogram is a quadrilateral where it has two different pairs of parallel sides. Basically like this picture here. The top and the bottom are parallel because it has the one little arrow marker on it. And the left and the right sides are both parallel because they have the two little arrow markers on it. So that's a parallelogram. Now we also learned earlier this year though, that these three shapes are also parallelograms. So a square has parallel sides, opposites, so it's a parallelogram. Same as a rectangle, same as what we call a rhombus. So let's review quickly what those shapes are. Square, very easy. Square means all four sides are the same and all four angles are right angles. Now in that case, the top and bottom are parallel, the left and right are parallel. Now a rectangle is like a square in that it has right angles, but the sides are not necessarily the same length. But again, top and bottom are parallel, left and right are parallel, so it counts as a parallelogram. Now the last one was a rhombus. A rhombus is one where all four sides are the same, like a square, but the angles are not necessarily right angles. And it ends up being top and bottom parallel, left and right parallel. So basically all four of these shapes count as parallelograms, and to find the area of any one of them, we're going to use the same formula. So I can find the area of any of these shapes using area equals base times height. Very, very simple formula, just base times height. And in fact, for a square or a rectangle, it's a very easy question because the base and the height are just the sides of the square or the rectangle. So let's say we're talking about a parallelogram. Let's say we're not talking about a square or rectangle. We're going to take our shape. We're going to, if it's not already, sometimes it's kind of drawn at an angle. We're going to imagine laying it flat on one of its sides. Doesn't matter which one, just lay it flat on one of its sides. Once you do that, the top and bottom become what we call the bases of that parallelogram, or we're going to use that for the base in the formula, area equals base times height. Now here's the one part that can be a little bit tricky. This is the part that's easy for a square or a rectangle. For a square or a rectangle, the height is just the other side of the square or rectangle. But for a parallelogram, which is kind of tilted sideways, the height is not the side of the parallelogram. The height is this imaginary vertical line, and it's basically the distance between the two bases. So let me show you an example of what I mean by that. So I said in this picture right here, let's say this is a parallelogram. And you know what, I didn't mark it, so let's add the arrows. Let's say there's one arrow up here and one arrow here to show those are parallel. And we'll do two here and two here. So we have a parallelogram. The base is 7. This right here is the base. Once I pick my side and kind of lay it flat like that, the length of the bottom or the top, which is the same, would be the base. So then you look at this question. We got to find the height. And you want to realize in this one, the height of this parallelogram is 4. It's not 5. So the 5 is kind of like that slanted line over there on the side. That's not the height of the parallelogram. The height would be the 4, which in this case, I just put the number in there. But I'm going to show you an example in just a minute where you have to find the height yourself. But to finish this question, if I ask you for the area of the parallelogram, it's a very simple question. Area is base times height. 7 times 4 is 28. Done. All right. Okay, so let's do that example I was talking about where we want to find the area of a parallelogram, but we don't know the height. I can see the height. It's that dotted line down the middle, but I didn't put a number there this time. So this is a two-part question. Before we can find the area of the parallelogram, we need to know the base, which we do. This 22 up here is the base. Doesn't matter if I give you the top or the bottom, those are both the base. So what I need is the height. So let's do this. let's put an x in here. I'm going to call that dotted line x, which is the height, and let's solve for x. Now when I think about how I'm going to do that, what I see if I look at the left-hand side is a right triangle. And when I see a right triangle and I have both a 12 and an 18 in there, I can use Pythagorean theorem to find the missing one. So let's do a squared plus b squared equals c squared. And remember the rule for Pythagorean theorem, find the right angle, use that to find the hypotenuse. The hypotenuse has to be c. So in this question, the 18 needs to go here. Now the x and the 12 can go in any order. So I'll just put x squared plus 12 squared equals 18 squared. Now let's do the squaring part. Let's leave the x squared. 12 times 12 is 144. 18 times 18 is 324. And then let's solve for x. I am going to subtract 144 from each side. And that gives me 180. So x squared is 180. And remember, when you're solving for x, if you get an x squared, you cancel the squared by taking the square root of both sides. So x ends up equaling the square root of 180. Now, the square root of 180 is not a perfect square. We don't want a decimal right now, not yet anyways. So let's either leave it as the square root of 180, or remember I said if you type it into your calculator, it'll reduce it for you. And when it reduces, you get 6 times the square root of 5. So leaving it as square root of 180 is okay for now. Simplifying it to 6 radical 5 is okay for now, but let's not go a decimal yet. And I've told you this in the past. If you round off a number in the middle of a question and then use that rounded off version, your answer could be off by a little bit at the end. We don't want that. So to finish the question, we have area equals base times height, which would be 22 times 6 radical 5. Now, again, if you want the exact answer, just do the 22 times 6 and leave the radical 5. That would be, let's see, 132 radical 5. Or you can use your calculator to get a decimal at this point. Remember, at the end of the question, if you want a decimal, that's fine. I'm going to leave it as 132 radical 5. But if you ever need your answer as a decimal, just type it into a calculator. That's fine. The idea there was we couldn't do that without the height. This was a two-part question. We had to use Pythagorean theorem to find the height, and then do area equals base times height. Okay, I want to do area of one more quadrilateral with you today. And first, let's review what a trapezoid is. So a trapezoid is another quadrilateral, 4 sides, where one pair of sides is parallel, but the other isn't. And there's a picture right there. So the top and bottom, although it doesn't have to be the top and bottom, you can kind of draw one on its sides like this. But you have 2 parallel sides, we call those the bases. Now this time the bases aren't the same length. Like in my picture, base 2 is much shorter than base 1. But the height is the same. The height is the vertical distance between the 2 bases. So here is a formula for area of the trapezoid. Area is 1/2 times parentheses base 1 plus base 2 times the height. Now here's a good way to think of it. This first part here, this 1/2 base 1 plus base 2, is saying I'm going to find the average base length. If one of my bases is short and one of my bases is long, I'm going to add them up and divide by 2 and I get exactly halfway in between the two. So then you take that number and you basically just do base times height again. So let's find the area of this trapezoid here. So what I have, my 2 bases are 30 and 16. So this 30 down here, this is a base. And this 16 up here, this is a base. Now what I'm going to end up doing is I'm going to take those 2 numbers, add them up, divide by 2, and get the kind of like average, or we called it mid-segment the first time through, the halfway between the 2 bases. Then I'm just going to do base times height with that number. But the first thing I need to do, like our last example, is find the height, because it's not given in this question again. So let me do this. I am going to draw in the height and call it x again. Now, I have a right triangle on the right side this time instead of the left side. And if you notice what's different, instead of giving you two sides, last time I gave you the 12 and the 18, and we did Pythagorean theorem. This time I gave you one side and one angle. If you want to find x, what you have to do is use SOHCAHTOA, another very important thing we learned this year. So let's review SOHCAHTOA. I'm looking at the right triangle over on the right side of my picture. If I label my sides, number 1, I can see that the 12 is the hypotenuse because it's opposite from the right angle. Now the other two legs, remember we want to call them opposite and adjacent. So the 30-degree angle is right here. Opposite means opposite from that 30-degree angle. So in this picture the x is going to be opposite and the bottom of the triangle, the blank one, is going to be adjacent. So here's how we use SOHCAHTOA. Let me write the word out. SOHCAHTOA. This is a SOHCAHTOA review for you guys, a very important topic. You're going to use this a lot. So I look at my picture and I say, if I want to solve for x, number 1, I want to use the x to solve for x. And number 2, I want to use the number that was given in the question, the 12. See, I can't use adjacent because I don't have a letter or a number down there. So I want to use O and H, opposite and hypotenuse. I look back at SOHCAHTOA, O and H goes with sine. So this is going to be a sine question. Now after you figure out whether it's sine or cosine or tangent, you always write the angle. The angle in this problem is 30, so I have sine of 30. And then you do the SOHCAHTOA part. So remember, the O and the H give you a ratio or a fraction. SOH means sine equals opposite, which is x, over hypotenuse, which is 12. So we have x over 12. And then we're going to solve for x. And I can do that by multiplying both sides of the equation by 12, because this 12 will cancel with this 12. And what I get is x equals 12 sine 30. And I'm just going to leave that for now. Remember, we don't like using a calculator in the middle of a question, so you don't really want a decimal answer yet. So now I'm ready to actually find the area of this parallelogram. So let's do what we call the mid-segment first. Let me add the two bases and divide them by 2. So I'm going to do 16 plus 30 and then divide by 2. I know in the formula it said 1/2 times. I like divide by 2 instead. Same thing. So 16 plus 30 is 46. And 46 divided by 2 is 23. So halfway in between 16 and 30 is 23. We're going to use that as our base. So now to find the area of this shape, all I have to do is take my kind of average base, which is 23, times the height, which is 12 sine 30. Now here is where we would definitely use a calculator. So let me see what that comes out to. We go 23 times 12 times sine of 30. We get 138. It actually wasn't a decimal. And that's measured in meters because everything in the picture was meters. Actually, that's measured in square meters. Area is always measured in square units. We talked about that earlier in the year too. So area is 138 square meters. Now, I want to show you one kind of interesting thing here. We're done with the question, but I'm going to go back and show you where this formula comes from while I have the picture on the board. Let me get rid of all my little marks here. Let's get rid of all this stuff and go back to the original question. So remember, when we found that mid-segment, the mid-segment goes through here and basically cuts vertically that thing in half. That's the one whose length is 23. Well, imagine taking this little piece of the trapezoid right here, cutting it off, and then filling it in right here. And then doing the same thing on the other side. Imagine taking this piece of the trapezoid, cutting it off, flipping it over, and filling it in up here. Now what you have is a rectangle where the width is 23 and the height is what we found. It was 12 sine 30. So that's kind of where the formula comes from. By finding that mid segment, you can really, like if you have made out of paper and you cut it up with scissors, by cutting the edges off and rotating them over, you can turn a trapezoid into a rectangle and then just do base times height. But the math says to find the base, you got to find the mid segment. So that's where the formula comes from. I just wanted you to see that before we finish. But that's our lesson for today, area of quadrilaterals. We're going to focus on parallelograms and trapezoids.